Hi and welcome to another mini lecture. Today's topic is trigonometric functions and special angles. We are focusing on degrees here. So once you are on a circle and you are measuring your angles from this standard position and you call this angle theta, you're at some location, say we call it X and Y. So you can think about it as having a triangle, if you wish, in this simple case where this is in the first coordinate X and Y and theta. We have six trig functions that are defined like this. First, we focus on sine and cosine. Sine of theta. Sine of theta, you might have learned it previously in terms of opposite divided by a hypotenuse. That is fine. You can think about this thing as opposite, this one as adjacent, and this one as a hypotenuse. If you haven't seen this terminology, just come along with the style that Alex and your textbook uses. They just go ahead and straight out define sine of theta instead of opposite or the hypotenuse. Let's just take y and be done with it. For cosine of theta, you have heard about adjacent over hypotenuse, but here from right off the bat we just define this thing as x. Tangent of theta, opposite over adjacent, it's just gonna be y over x. So let me just, for those of you who remember this from another style, perhaps from high school, this was opposite over hypotenuse, this was adjacent over hypotenuse, and this was opposite over adjacent. Then we have reciprocal of these quantities with the names cosecant of theta, so that's going to be 1 over y, and if you wish, hypotenuse over opposite, and secant of theta, that is 1 over x, and that is same as hypotenuse over adjacent. And this is cotangent of theta, that's going to be x over y, or in other words adjacent over opposite. So these are the six trig functions. As I said, here we are focusing on these two, and then later on we are going to look at tangent of theta as well. These three together form the primary trig functions, and the other ones are secondary, or if you wish to call them a hair and spare, or however you want to look at it. These three do not show up on most calculators, and you have to do one small step to calculate them yourself. Okay, so that's the definition of these six functions. A triangle has three sides, and you can make six ratios. Each of them have a name. One of the interesting aspects of trigonometry is the fact that you are referring to the same angle by six different ways, and that creates a rich background of relationship between these things. Okay, the way we can handle it is by doing a lot of practice until the topics become second nature. Now we are going to look at so-called special angles. You remember last time we had the following. If you have angle of pi over 4 or 45 degrees, these three sides were radical 2 over 2, radical 2 over 2, and 1. In a circle, the coordinates were radical 2 over 2 and radical 2 over 2, meaning this is x and this is y. If you are dealing with 60 degrees or 30 degrees, the triangle that you're going to be looking at, so this is going to be, say, 60 degrees. If this is 1, this is 1 over 2, and this is radical 3 over 2. Inside of a triangle, of course, these are going to be coordinates 1/2 and radical 3 over 2. If you turn this thing around, just the numbers change their place, but the triangle is the same triangle. So if you draw it like this, you don't need to memorize it all over again. But this, you think about this as the 30 degrees. This is 1/2. This is radical 3 over 2. And this is 1. Coordinates of this place is going to be radical 3 over 2 and 1 over 2. Okay, let me just mention two special silly looking triangles. Sometimes they help. What if you're dealing with the angle like 0 degrees? Well, 0 degree, if I wanted to draw it, will be just a line. So I'm going to exaggerate that 0 and just make it like this. So this 0 degree, this means I'm looking at 0 degrees, so that we have a way of referring to it. So this then of course is going to be 90 degrees, and the funny thing is that this is also 90 degrees. So 0 degree means the triangle has been collapsed. This side will be 1, this side will be 0, this side will be 1. A triangle like this helps us get certain values about 0 degree and 90 degree angles easily. So a few triangles to remember, and then we can be on our way. Okay, questions here. We have a bunch of angles, typically not in the first quadrant. So first thing to do is to figure out where this thing is. 300 degrees. You have two things. Put that circle in front of you with all of these functions attached to it, and the coordinates, and you can easily read it off from that circle. Or I would prefer if you reason your way to an answer as opposed to looking it up. So how do we reason? So the way we reason, first we try to figure out where we are at. 300 degrees, where is it? Well, we remember that 0, 0, 90, 180, this is 270. So we must be passing 30 degrees past that to make 300. Is that right? This is 30 degrees. That means we are 60 degrees left from a full rotation. So this is the triangle I'm looking at. This is 60 degrees. So this is the triangle we are trying to understand what's going on here. Okay. In a triangle, this, we remember this triangles we talked about here, this one or the other one. So this is 1/2, and this, due to the fact that we are below x-axis, is going to be minus radical 3 over 2. So this location has x of 1/2 and y of minus radical 3 over 2. Okay, once again, try to understand these triangles and then answer these questions by referring back to them, arranging your angles until picture reveals one of these things to you. If you don't like that approach, then put that circle with all the numbers on it and just operate like that. Okay, next, sine was what? Sine, of course, opposite over hypotenuse, and all of these problems, hypotenuse is just 1. Opposite for us is this minus radical 3 over 2. And remember again, exact value required. We're not going to type this thing on typical calculator, not going to report it as like minus 0.87, etc. That is not counted correct. Cosine of 315 degrees. What kind of? Okay, these are special angles. Where was 315? You have to remember from a prior lecture, where is 315? So again, we draw a picture. 315, 0, 90, 180, 270. This is going to be 360. So 315's landing somewhere between these. So if I'm at 315, how many degrees do I have left to go here? That's obviously going to be 45 degrees. So I have a 45-degree triangle here. 45-degree triangle here. 45. So that is going to be radical 2 over 2. That's my x. Y, we understand we are below the x-axis, is minus radical 2 over 2. This is the x and this is the y. Coordinate of this point is radical 2 over 2 minus radical 2 over 2. What is cosine? Cosine is just x of this point. So the answer is going to be radical 2 over 2. Let's do one more. Cosine of minus 225 degrees. So again, we try to figure out where we are at. Minus, so we are going this way, 0, minus 90, minus 180, minus 270. We are in between. Well, from 180 to minus 225, how many degrees left to go? This is 45 degrees left to go. This is the triangle we are looking at. So we know sides are radical 2 over 2. How about plus or minus of it? So this, of course, is minus radical 2 over 2. The height is radical 2 over 2. So the coordinates of that point is minus radical 2 over 2 and radical 2 over 2. Cosine corresponds to what? Corresponds to this x. So minus radical 2 over 2. That is the answer for this. Again, I insist, try to reason your way to an answer. Sine of 120 degrees. Where is 120 degrees? 120 somewhere here, 120 degrees. How much is left? 60. So I'm dealing with this triangle here. This is a 60-degree triangle. 60, this is 30. That's going to be 1/2 and radical 3 over 2. So coordinate of this, that's going to be 1/2 and the other one radical 3 over 2. 1/2 and radical 3 over 2. What is sine? Remember we said sine is the y coordinate. Second coordinate is the sine. So this becomes radical 3 over 2. Okay, so keep practicing on these things. Come back to it every other hour. Look at it until you're comfortable. So these have to be as comfortable to you as 1 plus 1 being 2. You're going to be living with this thing for the next few years, so you have to be comfortable. Okay, until next time, good luck and God bless.